Hello everyone, in this video we are going to see about the knapsack problem and let us see the greedy approach of how to solve the knapsack problem. Okay, so let us see first of what is the problem and then we will go for the solution. The greedy method suggests that one can devise an algorithm that works in stages considering one input at a time. So what is the greedy method is, you give one input at a time, we check whether the input is optimal or not, then if it is okay, we will add, otherwise we discard. That is the greedy approach. At each stage, a decision is made regarding whether a particular input is an optimal solution or not. This is done by considering the inputs in the order determined by some procedure, some selection procedure. And if the decision inclusion of the next input into the partially constructed optimal solution results suboptimal in or infeasible solution, then the input is not considered. Okay, so this is how the greedy approach works. So we choose an input, we look for the possible output with this input. If it is not optimal, we discard it. If it is optimal, we include the input. This is how the greedy approach is taken. Now let us see. Otherwise, okay, that is the procedure. The selection procedure itself is based upon some optimization measures. So the selection also we won't make it simply a selection. We follow some procedure. Maybe some order, increasing order, decreasing order, or some any procedure we can use for the selection. Okay, so this is the general algorithm procedure greedy a comma n. So a is an array of n inputs and solution initially is equal to 5. That is null set, and then we start with the solution with the empty set. For I is equal to 1 to n, do x is equal to select of a. So once you select from the array input and put it in x variable, and if this joining of this earlier solution with the x, that means if feasible of solution comma x, then solution is equal to union of solution comma x. That means we join the solution, previous solution with the current x input if it is feasible. Otherwise we discard it. Now the loop goes end if and then repeat. So now this loop repeats for all the number of inputs in the array and the greedy procedure is closed. This is how the greedy approach takes place. Now let us see the problem statement. Before that, we have two types of knapsack problem: fractional knapsack problem and 0/1 knapsack problem. Here the problem is we have a bag when you have to add some items into the bag. We may add either partially the items or fully the items. If we add the items fully, it is called as 0 or 1 knapsack problem. If we add part of the items, that means if the item is breakable, we can break some item and put it into the bag, that is called as a fractional knapsack problem. So normally 0/1 knapsack problem we have solution using the dynamic programming concept, whereas for fractional knapsack problem we follow the greedy algorithm concept. Okay, so now let us see the problem statement. So the problem statement says a knapsack, it's a kind of shoulder bag with limited weight is given and few items are added, and adding this item into the bag creates some profit. Okay, let us see. This is the problem and you can see the bag also. We have object I with weight wi and the maximum capacity of the knapsack is m, and xi is the fraction of the object and paxi is the profit earned while adding the object to the knapsack. So this is the diagrammatic representation of this knapsack. We have a knapsack of 15 kg and we have so many objects of 1 kg, 2 kg, 3 and 4, and this dollar symbol gives the profit which created by the adding of this input. Okay, so now this is the problem statement. As I told you, now we have objects and fraction of objects xi, capacity of the bag is capital M, and then we have profit earned is paxi and the weight is wa into xi, and we have to maximize the profit and the maximum capacity is also given. So we have to follow these constraints. So mathematically how to represent this problem? Okay, so maximize sigma pi xi, xi into pi is the profit, that is the equation A, subject to the constraint wi xi less than or equal to m, means that cannot exceed the capacity of the knapsack bag. Okay, So the weight or the capacity should be less than or equal to m. We cannot put more into a bag which beyond the capacity. That is the constraint. And then this xi is between 0 and 1. So it may be 0 or some fraction or 1. That means we may include the object or not. That is 0 or 1. Partially or fully. Means 1 or 1 by 2 or 1 by 3 or 1 by 15. Any part of the, any fraction of the object can be added to the knapsack bag. Okay. And I between 1 and n. This is the condition C. Now the profits and weights are the positive numbers. It is obvious. And a feasible solution is any set xi, x1, x2, etc. xn satisfying the rule B and C. And an optimal solution is feasible solution for the which rule A is maximized. That means we have to maximize the profit subject to we do not exceed the capacity of the bag, and also the objects can be put in a fraction. Okay, now the solution are, now example is given, n is equal to 3, m is equal to 20. That means n objects, 3 objects are there. Capacity of the bag m is 20. We have profits earned is P1, P2, P3, which is 25, 24 and 15. And the weights observed, weights of the objects is W1, W2, W3 is 18, 15 and 10. And we can have different feasible solutions. So we can have many feasible solutions, and one must be the optimal solution. Okay. So now here the first thing is that we try to fill the objects by adding the objects in some manner which is in some sorted order. Okay, so in some order, so we are using either 1 by 2. Now we are taken as a sample 1 by 2 of first object, 1 by 3 of second object, and 1 by 4 of the third object. So accordingly the summation WXI is given as 18 into 1 by 2, because 18 is the profit of the first object, that is a weight, and the ratio is 1 by 2 for the x1, so 18 into 1 by 2, and weight of second one is 15 and the ratio is 1 by 3, so 15 into 1 by 3, and the weight of third is 10 and the ratio is 1 by 4, so 10 into 1 by 4. So summation of these values will give 16.5. That means we achieve 16.5 as the weight of the object. Okay, and putting these weights into the sack, we get the profits 24.25. How come this value comes here? Because we have profits as 25, 24 and 15. The ratios are 1 by 2, 1 by 3, 1 by 4. So multiply 25 into 1 by 2 plus 24 into 1 by 3, and the third one is 15 into 1 by 4, which is 24.25. That means adding these weights to the knapsack will create the profit as 24.25. This is one possible solution, feasible solution. Now solution 2, select the object with some maximum profit. Here the profit maximum is 25. So we choose the full profit, which is 25. So the object weight is 18. Okay. After that we have only 2 units of weight left out. So we have to add only 2 units of the object. That means we are going to 2 units of the object which has the next maximum profit, which is 24. So we are taking 2 by 15th of the 24th profit. That means the second object. So we are multiplying 15 into 2 by 15, because 15 is the weight of the second object, and adding these 2 will give the maximum capacity of 20 as the bag capacity. So 18 is already got by the first item, plus 2 we are adding to get the summation as 20, because we cannot exceed the value beyond 20. Okay. So while adding these weights to the bag, the profit gained is 25 into 1, because we are getting the full profit of the first object, plus only 2 portions of 15 can be added. That means 24 into 2 by 15, which is 28.2. Adding these values 25 into 1 plus 24 into 2 by 15, which gives 28.2. So the profit gained is 28.2. Earlier it was 24.25. So we have tried 2 methods. One is by giving some order of the object. Second is choosing the maximum profit. Now let us go to the third solution, where we are having the another criteria or other selection procedure. Here it says that considering the objects in the order of non-decreasing weights, we are using the non-decreasing weight of the objects. So here x is minimalized, which is 0, because we assume that the weights are in the non-decreasing order. That means it should be increasing in the sense. Okay. So 18 is the maximum, so we discard it. And next 10 we can take it as fully because that is the minimum weight. And then in order to solve the remaining 10 weight, we can add some portion of the second object. Okay. So how much we can add of the second object is we can add 2 by third of the second object. So last one is minimum weight is 10 added fully, and then the next one is we are adding 15 into 2 by 3, which will give some 10. Okay. So 10 plus 10 is 20. So we have achieved 20 as the maximum weight. So no need to include the third one. By this we get the solution as 24 into 2 by. So whatever the ratio you apply for the weight, you should apply the same for the profit also. Okay. So 24 into 2 by 3 plus 15 into 1, which is 31. This is giving some little higher values as the solution. Now we go for next greedy approach, that is the fourth solution, where we choose the order of ratio of Pi by Wi. That means we are using the Pi Wi ratio as P1 by W1 is 25 by 18, 1.4. Likewise, P2 by W2 is 24 by 15, 1.6, and P3 by W3 is 15 by 20, which is 1.5. Okay. So among these three, 1.6 is the highest. So we have to choose the highest Pi by Wi ratio. So choosing the highest Pi by Wi ratio, we are choosing the second object as a full. Okay. So once you choose the second object as full, we have achieved the weight of 15. Okay. And in order to complete the weight, we have to add half of the third one. So we are adding 5. Half of the third means 10 into 1 by 2 is 5. So 10 plus 15 plus 5 is 20. So the weight is completed now. So accordingly the average. And one more thing is that actually we are following the Pi by Wi ratio. Highest is 1.6, the second one. Then the next highest is third object, which is 1.5. So we are choosing the second object. So the second object is chosen because it has the next highest Pi by Wi ratio. In that, in order to fill in the maximum capacity of the bag, we are choosing only half of the weight, because then only that is only possible, because already 15 is added at the weight, only 5 is remaining for the capacity of the bag. So we are adding only 5 from the second one. That means half of the weight of the second one. Okay. So which is second weight means second profit one, which is the third one. Okay. So 10 into 1 by 2, which is 10, which is 5, and 15 plus 5 is 20. So capacity is reached, as well as the same is applied to the profit also. So 24 into 1, second is taken full, plus third one we are taking half of that, which is 15 by 1 by 2, 15 into 1 by 2, which is 7.5. So adding this 24 plus 7.2 is 31.5. So we came across different methods. Now we found this 31.5 is the maximum profit, which is the optimal solution. So we have come across so many feasible solution, but what we got finally now fourth is the optimal solution. Okay. So all the values are listed here. Now the values are listed. One by one. So we can see here the first one, as we did, 24.25, second one is 28.2, and third another different ratio 31, and the fourth is 31.5, and the fifth one is 30, and the sixth one is 28. So among all these things, the fourth value, which is the 31.5, is the optimal value. So this is how we are choosing the greedy approach to solve the problem. So our aim is to get the maximum profit by different orders of putting the portions of the objects into the bag. So this is how the knapsack problem is solved using the fractional knapsack problem of the greedy approach. We are greedy to get more profit from the order we arrange. For that, we are looking for so many solutions, and once the best solution is achieved, we are choosing that as an optimal solution. Okay. So hope this is easy to follow, and thanks for watching.